Hi, today I will talk to you about a new chemical release calculator app. If you work at an industrial facility, there's a good chance you may be involved in a process leak. Quick Release is a simple app used to estimate the amount of a vapor or liquid released from its primary containment. In industrial processes, leaks do occur. Gases or liquids escape to the environment, can cause harm to people, the environment, or equipment. In many cases, leaks are small, but without an idea of the quantity, plant owners or operators can often make decisions that cause more chemicals to be released to the atmosphere. For example, a decision to shut down a running plant. In other cases, the leak may be small at first, but increases, let's say, exponentially with time, often unknown to the owners or operators. Quick Release is designed for operators. However, it can be used by engineers, technicians, safety personnel, environmental personnel, students, and management. To start the app, click on the icon shown. On the welcome screen, you can review a brief description of the app, the disclaimer, and the limitations of liability by clicking the info button. You can also go to the Facebook page related to the app by clicking the Facebook button. And you can also look at a demo of this video by clicking the demo button. If you have great ideas for apps that can help operators or engineers, please share with us. You can click here and share your app ideas with us. Click to proceed to start entering data. On the timer screen, you'll see there are a number of steps. Step 1, Step 2, etc. There's a start timer and there's a reset timer. Press start timer if, when the leak is discovered, it continues to leak. This will give you an idea of the amount of time that you have while calculating before you have to call the NRC or make notifications. For example, click Start Timer. You'll see the timer starts. You can pause, you can start again, or you can reset the timer. Let's go ahead and leave the timer running. You can also click each step to get an idea of what the step involves, what is required for the step. For example, if I click Step 1, it tells you to press Start Timer only if leak continues after leak was detected. If leak has stopped, then go to Step 2. You can also click Step 2 to get an idea of what it does. Enter the number of hours and/or minutes the leak continued before you started this app or before you press Start Timer. So in this box, let's say the leak persisted for about, let's say 20 minutes. You click 20, then you hit Done. Then you go click Next. On the definition screen, it's going to ask you several other questions. Step 3 says, can you see the hole or the crack? Now, oftentimes there are leaks where the gas makes the area so cloudy that it's difficult to see exactly where it's leaking. If you can't see the hole or crack, click No. Otherwise, click Yes. The default is always the one in black, which is yes. Then it's going to ask you what medium is affected. For the medium, it can be either ground, air, or water. In this app, it can only consider one medium at a time. So you may click air if it's a gaseous release or water. Let's say it's a liquid release. Then it's going to ask you to select the phase of the release. Once again, this app is only for single phases. It cannot do dual phases. Next, click whether suppression was used. Now, for suppression, the result of the app does not include correction for suppression. You are responsible for correcting the result of suppression. And the reason for this is if you suppress the gas but you don't contain it, then it may still be a release to the environment. So you would have to calculate whether or not suppression is required and then use your calculations to reduce the amount generated by this app. Go ahead and click next. In this scene, it's going to ask you what type of stream it is. Now, just click on any one of the streams if it closely relates the stream that you're seeing for a gas. For example, in a jet stream, the pressure is high. It's entering the atmosphere at a high velocity. So you can click here for jet stream or click here for a wisp where there's a wisp of smoke in and around the area. Let's click jet stream for now, then click next. Step 8 is going to ask you what type of opening is it. Is it an ROV? Is it a flange? Is it a hole? Is it other? Let's click hole for now. Step 9 is going to ask you the shape. The default is circular. Let's leave it as circular. And then it's going to ask you for the dimensions. Now, for a gaseous leak, you really want to try to use inches and your dimensions in inches. If you have a gaseous leak and you use dimensions in feet, for example here, then the quantity calculated is going to be quite large. So let's stick with inches for now. Usually cracks are very, very small. Let's say we have about a point 1. Oops. Let's say we have a 0.1 inch crack and click done. Okay, let's go to next. As you come to the process, it's going to ask you what is the process condition. So let's say the process condition is 300 psig, or you can click kilopascals. Let's stick with psis for now. And let's say the temperature of the process is operating at 150 degrees Fahrenheit. Click done. Next, you click choose chemical. Now it's going to give you a range of chemicals to select. You have two choices. You can either scroll the chemicals or you can go to the search bar at the top and then type in the chemical that you're looking for. Let's say ammonia. As soon as you click the chemical, it's going to give you the RQ amount and click accept. Great, you're well on your way. You're almost there. Okay, the next step is going to ask you for the percent of the release. And what this is asking is how much of the total gas release is this chemical? For example, ammonia. So if you have only ammonia release, then the percent of the release would be 100%. However, if it's ammonia and nitrogen release, let's say the ammonia only makes up 20% of the gas, of the total gas stream, then you'll put 20% here. Now, you have the option of adding another chemical. Let's say we want to add nitrogen. Let's see if we can find nitrogen. Nitrogen. Okay, there's no nitrogen. There's nitrogen dioxide and there's nitrogen oxide. So no nitrogen. Since it's not in the chemical list, go ahead and click cancel. Go back to your process and then just type in. Go ahead and type in here nitrogen. And then type in the amount of what percentage is nitrogen. So let's say nitrogen makes up the rest of the gas. So let's say 80%. Okay, when you click enter, it's going to ask you to verify with engineering. And basically what that is saying is just to make sure that the ratios that you use, the percentages that you use are correct. So you can verify with engineering, but if you know what it is already, then just go forward. Now you can see for the first chemical, ammonia, it gave you the RQ limit. But the second one, nitrogen, it wasn't in the chemical list. Therefore, you have to put what the RQ limit is for this one. So let's say it is 1000. Okay, step 14 is going to ask you to enter the engineering values. Now, these values are critical for any calculation. However, in the quick release app, you do have a number of default values shown here. For instance, the expansion coefficient being 1, correction factor, and molecular weight being 27.4 for the gas. Let's say for a mixture of ammonia and nitrogen, it's going to be in this range. So if you don't know, you really want to consult with your engineering department, your process engineering department, to get these values. But let's go ahead and stick some values in here. Let's say expansion is, let's say 0.7. Let's say C is 0.8. And let's say the molecular weight of this gas is 28 point, say 28.0. Okay, after you enter those values, you're going to hit results. And those are your results. Now let's go through the result page. You can see the timer is still going, and it's going to ask you to press the stop timer button. If the release or if the leak continues in the field, then you want to leave this timer going, or else you can go ahead and stop the timer. Let's go ahead and stop the timer. Okay. Prior to the timer being stopped, you'll see that the amount of the release continued to increase. And as soon as you stop the timer, the release is a fixed number. In step 15, there's also the opportunity to go from US units to metric units. So you can go ahead and click metric if you prefer it in kilograms, or you can go US units. Step 16 is going to ask you to press whether you want to see detailed results. In this particular format, your results are simple. So it's saying 19.58 pounds of ammonia released and 78.31 pounds of nitrogen released. If you want to see detailed results, you can click detailed, and then it's going to show you results for ammonia, and you can scroll these results. For example, you see the release rate is 42.56 pounds an hour. Pounds since the timer started was 5.38 pounds. Remember when you started the timer at 0. Pounds released before the timer was started was 14.2 pounds. Total pounds since leak started, this 19.58 would be your simple results. The reportable quantity for ammonia is shown as 100 pounds. It's showing you that the percent of threshold, so there's a percent of 100 pounds, you're actually 19.6% of your threshold, which is 100 pounds. And it's telling you in 2.5 hours, you're going to reach that 100 pounds. So you want to make sure you do something within 2.5 hours. The quantity released in 24 hours is going to be 1,021 pounds. So if you leave it all day, it's going to exceed this 100 pounds shown here. Then you get similar results for your second chemical, which is nitrogen. It's going to tell you the release rate, pounds per hour, the amount released since the timer started, pounds released before the timer was started. All right, total pounds. The reportable quantity, this was the 1,000 pounds that you entered, the percent of threshold, etc. If you want to go back to simple results, just click here, and it's going to go back to the simple results. At the very bottom of the page, step 17, you can email results, and it's going to include your engineering values. So click here to email your results. And that ends the app. You can start the process all over again for a different chemical, by just clicking the Start Over button. And that's all for this app. It's a pretty nifty app, and it does save you a lot of time. You can see here that you were able to calculate what that release was within 7.5, just over 7.5 minutes. And remember that you have 15 minutes to make a decision, so you were well within time. And you have an idea what that release was. So you can make a good decision on what you can do within the plant to stop that release, prevent it from going any further, to make better decisions. Okay, so that's some of the benefits of the quick release app. Again, it can be used for almost anything. You can use it to estimate steam, you could use it to estimate vapors, you can check to see how quickly a gas or liquid is escaping. There's a lot of benefits to having this handy. Again, it works only on your phone, on your iPhone for now, but it's something you can pull out relatively quickly when you're in the field. Pull it out, plug in your values, and you get a result very, very quickly. So those are some of the benefits of having this on hand. Again, at the end of the day, it does help to make better decisions where releases are concerned. If you want to get a copy of the quick release app, just go to the app store. It's available on the you can search quick release, or you can search leak calculator, leak calc, and you'll see the nice blue icon show up at the top. So that's all I have for this app. Hope it brings you a lot of value, and hope you use it often. Thank you.